Okay, so we're going to tackle these guided practice problems. So number one, let A be the area of the region that lies below the curve f of x equals 4 minus x squared between x equals 0 to x equals 4. Okay, so if I'm going to draw that, let's sketch that out over here. I'm going from 0 to 4. And let's see, when I plug in 0 for x, my y value is 4. And let's see, this is a parabola that opens down. So when I plug in 2, I will get 0. So this is a point here. And so my curve goes something like that, which means that the area under the curve is actually some positive area. And also some negative area, which kind of throws a little bit of a wrench, but doesn't really matter for our concerns. Okay. All right, so using right endpoints, find an expression for A as a limit. So for A is going to be, we know it's the limit as n goes to infinity of delta x times the sum I equals 1 to n of f of x I star. Okay, now remember that for our right endpoints, that's going to be these ones. So 1, 2, 3, 4. If we're thinking 4 rectangles, we're skipping x0, and this is your xn. So we're starting from x1 and working our way up to xn. So that means that we also need to figure out our delta x. So our delta x is 4 minus 0 over n, so 4 over n. And that means that our xi's, so x1, we're starting from 0, so x1 is 4 over n. x2 is 2 delta x's, so that's going to be 8 over n. And x3 is going to be 12 over n, so xi is going to be 4i over n, right? It's usually your delta x times I when you're working with right endpoints. So that's what we're going to be plugging in for our xi, and that, or our xi star really, and that goes into the function, which is our 4 minus x squared. So here's what we get. We get the limit as n goes to infinity. Our delta x is 4 over n. We're summing I equals 1 to n, and our function at xi, our function is 4 minus, and instead of x squared, I'm going to use my xi, which is the 4i over n squared. Okay, so we leave it just like that. Down below here in part B, we're going to estimate the area by taking sample points to be left endpoints and using 4 subintervals. So I'll redraw this again for you. So we've got 1, 2, 3, 4. Again, 1, 2, 3, 4 on the height. We're crossing at 2. And I didn't hit my button, but it didn't hit the point, but you get the drift. And we've got this area along with this area. Okay, and so I'm going to get 4 rectangles, but I'm going left endpoints. So that means I'm going out from this left one to create my first. Left endpoints on the second, left endpoint on the third, and left endpoint on the fourth. So those are my rectangles. So they're going to look like this. Okay. And we're going to find our left 4 is our delta x times f at 0, f at 1, f at 2, and f at 3, because we're using those left endpoints. Our delta x is, let's see, so our delta x is 4 minus 0 divided by 4 subintervals gives us 1. So delta x is just 1. And then we're plugging in. So remember that we're working with y equals 4 minus x squared to plug in. So when you plug in 0, you get 4. When you plug in 1, you get 3. When you plug in 2, you get 0. And when you plug in 3, you get -5. Right? Because 4 minus 9 would give us -5. And when you add that up, 7 minus 5 gives us 2 as our area. Okay. Perfect.